Today's lesson is entitled Putting It All Together, and it deals with unit analysis and a term called stoichiometry, which is a chemistry term that relates to the amounts of reactants and products in a chemical reaction. So that's what we're dealing with. So this should be review for you. This is the equation we had for the explosion of our nitrogen triiodide. And last time we had a whole worksheet on that. You had to figure out how many grams or how many moles of one of the reactants or products. But I gave you all of the equivalencies. From now on, you are going to have to look up the equivalencies for yourself. So let's review what kind of equivalencies do you know or know how to look up. So at the beginning of the year, we talked about the atom. So we learned that 1 mole of anything, so we could say 1 mole of nitrogen, for instance, equals 6.022 times 10 to the 23rd atoms or molecules. So this is called Avogadro's number, and we used it to solve some problems. But you should know that 1 mole equals 6.022 times 10 to the 23rd. We also learned that you could look up on the periodic table the molar mass of nitrogen. So if I look up nitrogen on the periodic table, it's 14.0067, and 2 nitrogens happen to weigh 28.0134 grams of nitrogen. And I could do that for each of the compounds or molecules that are involved here. I could look that up for nitrogen triiodide, or I could look it up for iodine also. So I can look up things off the periodic table. And the last thing that we learned in the last video was I can also use the balanced equation, and I can use the coefficients to the balanced equations. And when there's nothing there, that implies a 1, to also relate moles. So I have things like 2 moles of nitrogen triiodide will give me or produce 3 moles of iodine. So let's review. What can I look up if I'm solving a problem involving the explosion of nitrogen triiodide? Well, I could look up the amount of atoms in a mole, which happens to be Avogadro's number. I could look up on the periodic table. So this is from the periodic table. So PT, periodic table. This is Avogadro's number, so I'm going to call that AN. And here, this relationship here, I can get from the balanced chemical equation. So I'm going to say balanced equation. So I can look up all of these things myself now because I know the tools to do that. So when do I use Avogadro's number? When do I use the periodic table? When do I use a balanced equation? Well, if the question that you're trying to solve asks you about number of atoms or number of molecules, or gives you the number of atoms or the number of molecules, you need to use this one. If the problem involves grams, like you're given grams or you want to find grams, you want to use this one. If the problem involves different elements, so if you are changing from one chemical to another, you need to use the balanced equation. The one part that becomes difficult is what happens if the problem involves moles. All of these 3 things relate to moles. So this one will help you with atoms and molecules, this one will help you with grams, and this one will help you if you want to change the chemicals from chemical A to chemical B. So let's give this a try and see if you can follow along. So here we have the question and the equation again. It says, how many grams of iodine are made from 13.7 grams of nitrogen triiodide? So hopefully you get used to solving these all the same way. We're going to put equal sign here, and because I've run out of room, I'm going to put it below the equal sign. I'm trying to find how many grams of I2, so I'm going to put GI2. So that's where I'm going. What did I start with? I started with 13.7 grams of nitrogen triiodide. So now I have to get rid of grams of nitrogen triiodide and get grams of iodine. So how do I do that? Well, the first thing I have to do, I'm going to put this over the number 1, is cancel out grams of nitrogen triiodide. So we just went through things I could look up. I could use the periodic table, I could use the balanced equation, I could use Avogadro's number. Well, the only source that tells me grams is the periodic table, so I have to use the periodic table next. So I would add 1 nitrogen and 3 iodine together, and I get a mass, which I'm going to put on the bottom to cancel out, 126.9 grams of nitrogen triiodide for every 1 mole of nitrogen triiodide. I'm going to have to try to write small so we can get it on the screen. So now I have moles of nitrogen triiodide, but I want grams of iodine. So I need to keep going until I get to grams of iodine. So what can I use next? Well, I just used the periodic table. Do I need Avogadro's number? No, there's no mention of number of atoms or number of molecules. And I've already used the periodic table. What could I use? I could use my balanced equation because I want to change nitrogen triiodide to iodine. So I can use the balanced equation. It tells me there are 2 moles, because 2's in front of the nitrogen triiodide, there are 2 moles of nitrogen triiodide for every 3 moles of iodine. Notice the problem doesn't involve nitrogen gas at all, so I don't need to use that. So every time I react 2 moles of nitrogen triiodide, I will obtain 3 moles of iodine. So now let's cancel these out, cancel out, cancel out. I'm at moles of iodine, but I wanted grams of iodine. So I'm getting pretty close. Now I want to get to grams. Well, what helps me get to grams? There's only one thing that helps me get to grams, and that's the periodic table. So I'm going to use that next, but this time I'm going to look up the molar mass of iodine and multiply that by 2. And I get there are 126.90 grams of iodine for every 1 mole of iodine. So I got this information from the periodic table, this from the balanced equation, this one from the periodic table. And notice these cancel, and I have grams of iodine. I wanted grams of iodine, so I'm done. So now I just need to take out my calculator and put in 13.7 divided by 126.90 times 3 divided by 2 times 126.90. And I get a very long number, 6.6067 something, but I only need 3 significant figures, so that gives me 6.61 grams of iodine. So there, I've solved the problem. Without being given any equivalents, I just looked them up myself and I could solve the problem. So let's try one more so we get a little bit more practice. Same equation, we're just using this same explosion of nitrogen triiodide. And the question this time is how many grams of nitrogen are made when 7.8 moles of iodine are made? So they're both being made. How much of grams of nitrogen do I get? So I'm going to write over here, put equals, and I'm going to put it down here because I might run out of room. So I'm going to grams of nitrogen. What am I starting with? I'm starting with 7.8 moles of iodine. All right, and I'm going to put that over the number 1. Well, I can see there's grams in this problem in moles, so maybe I'm going to use the periodic table next. So I'm going to look that up. And I look up iodine, and notice I'm very careful in these problems to write not only moles, but the chemical that goes with them. Because moles of iodine and grams of nitrogen, both parts are important. So let's look up on the periodic table. Once again, iodine times 2 gives me 126.9045 grams of iodine. Gave a couple extra sig figs this time for every 1 mole of iodine. So that cancels out. Am I done yet? I'm at grams of iodine, but I want grams of nitrogen, so I'm not done. So I need to cancel out grams of iodine. Well, where can I find grams of iodine? Well, I can find that off the periodic table. So I look iodine up, and I get 126.9045 grams of I2 for every 1 mole of I2. Oops! Look what just happened. I canceled it out, but I just repeated myself. I had grams of iodine here, grams of iodine here. I'm left with moles of iodine. I didn't go anywhere. What does that mean when I kind of just went around in circles? That means that I chose wrong. So sometimes you'll choose wrong and you'll either get stuck or you'll find yourself repeating circles. So I'm going to go back and undo what I just did. This is going nowhere, just back to where I started. Cancels each other out. So I should have chose something else. Well, periodic table was wrong. Avogadro's number, maybe I should have done that. No, I have no mention of number of molecules or number of atoms, so that doesn't seem right. Well, I could use the balanced equation instead. So let's try a balanced equation. And here I have 3 in front of iodine, so I have 3 moles of iodine. And I'm going to nitrogen, so this time I want nitrogen, and there's nothing in front of nitrogen, so it implies a number 1 mole of nitrogen. And now that cancels, right? Let's see if this is a dead end or if this will help us. Moles of nitrogen, and I want to get to grams of nitrogen. Well, I'm pretty close. If I want grams, I'm going to use the periodic table. But this time, I'm not using iodine, I'm using nitrogen. So I look nitrogen up on the periodic table, multiply that by 2, gives me 28.0134 grams of nitrogen. And the mole goes on the bottom so it can cancel for every 1 mole of nitrogen. And that cancels, and that's what I want. Grams of nitrogen is what I want here, grams of nitrogen. So I'm going to do my calculator, 7.8 divided by 3 times 28.0134. And I put that in and I get 72.8348. That's kind of long. I only need 2 significant figures because these are definitions and this is way more than 2 over here. So I only need 2 significant figures, so that gives me 73 grams of nitrogen. And I forgot on that last problem to check my work, which you should always do. Moles do cancel of iodine, moles of nitrogen cancel. I'm left with grams of nitrogen. And there I have my final answer. So don't forget, if you get in a circle or a dead end, it just means you chose the wrong thing to use. So try something else. Periodic table wasn't the right answer. Use your equation, use Avogadro's number, and just erase it. It doesn't take that much time to redo. So good luck on the problems. Hope you enjoyed this lesson.